Alright students, we are going to do the last of the concrete and formal proof examples together, and I encourage you to try this one before you watch the screencast, or pause throughout the screencast to try to finish things on your own and that kind of thing. So our conjecture this time is the sum of any two consecutive odd numbers is always a multiple of 4. So we're going to do the concrete example first, just like we have the other times. And we start our concrete example with a numeric example, and then we take it further than that. So we need two consecutive odd numbers. Again, I don't want to start too small. I don't want to get too big. So I think I'll try 7 and 9. Seems like a pretty good compromise. Let's just do a quick check. 7 plus 9 is 16, and 16 is a multiple of 4. All right, so like with all the others, we're going to start. I'm going to represent 7. I'm going to represent 9. All right, and now what we want to do is pull these down into the sum circle, and we want to do that in such a way that we know that this is going to always be a multiple of 4. So remember when we were looking for an odd number, we brought them down in pairs and then made sure we had that 1 left over to turn it odd. When we were trying to show that it was a multiple of 6, we brought it down in 6s. And when we are going to do this multiple of 4, we want to bring them down in 4s. So we want to take 2 from each circle. I'll try to show that the best I can. You guys can probably be a lot neater than me when you're not using this internet pen. But there's my first group. Another group. Let's see, I'll put these together with these two. Pull that down here. Okay. So far I've just been taking 2 from each group and pulling those down to make a set of 4 because I know that that keeps things with a multiple of 4. Well, now I have run out of pairs, so I can't keep doing that same strategy. If the numbers were bigger, I'd have pairs for quite a lot longer time. But what I notice, and this always works out so nice, but then we have to explain it, is I have 1 in this circle, and I've got 3 left over here. Those together, of course, make another set of 4. I've moved all of the x's down into the circle. They're in sets of 4, so I know that this is a multiple of 4. But I have to come up with an explanation here. I can't just draw the picture. So my explanation is, I bring down in sets of 4 by taking 2 from each circle. And when I run out of pairs in the first circle, I'm going to have 1 left over. I know there's going to be 1 left over because it's an odd number. And once I run out in the first circle, I know that there's going to be 3 more in the second circle because these are consecutive odd numbers. So that next number is going to be 2 higher. It's going to have 2 more left. So there's going to be 1 left, 3 left together. That will make 4 left. So I'm going to pause and write that. All right, so there's my explanation, and you can pause and read that It's essentially the exact same thing that I said before I paused the video. So we're going to come over here. We're going to do the formal proof. We're going to start it the same way as every formal proof that we've done. We're going to say let n equal a natural number. Okay. Again, natural number means 1, 2, 3, 4, 5, and so on. So natural numbers are both odd and even. So we can't use just plain old n in our proof because our proof has to be about consecutive odd numbers. And we have to make sure that we have odd numbers to work with. So in the last proof, we needed to deal with even numbers. So we used our little trick where we said, hey, 2n was even, and we let that be our even number. So we're just going to add on to that. If 2n is even, and again, think about that. If I take a number, I take a natural number, and I double it, it's always even. This is my way of making sure I have even numbers. So if this is even, if I add 1 onto that, then I know it's odd. And I need a number that is an odd number consecutive to the one that I've already made. So that's going to be 2 more away. So that's going to be 2n plus 3. Is consecutive to my first number. So now I find the sum. That is 4n plus 4. And I'm going to do the same thing I did last time, which is I'm going to factor out a 4. And then I'm going to write the statement, any number. And remember, the n plus 1 is my any number, multiplied by 4 is a factor of 4. And that's it. So you guys are going to work on these in the discussion prompts, do the best that you can, and then make sure that you are watching what your classmates write, and I will jump in to make sure that everybody is seeing correct proofs. Thanks, that's it.